that are big enough for you to digest for real deep training. So we focus a lot on day of sessions. We have a day of session on threading. We have a day of session on performance, a day of session on Silverlight, where we focus very, the whole day is dedicated to you to really learn that technology. We also don't limit ourselves to 1.5-hour sessions, right? If debugging takes more time, we do multiple sessions on debugging. But for you guys that are attending, and I hope I can get to meet all of you in Austin, Texas, if you use the registration code LDU when you go to the winelect.com site to register at Discovery, we'll give you $75 off. So I hope to see everybody at Austin, Texas. It's a beautiful time of year down there if you've never been there. So that's it for the slides. We're going to do demos for the rest of it here. And first off, let's talk kind of quickly about the top 3 things that you as a .NET developer care about. Okay? Let's think about this for a minute. What are the top 3 things you care about? Is it the vacation pay and benefits? Unfortunately, it's not. So what we've got here for our top 3 things, let's talk about this. From a developer standpoint, the number one thing you care about is memory. Okay? Memory, right? Because isn't .NET wonderful? Hey, we've got this beautiful garbage collector. We don't have to worry about things. And what do you worry about most? Memory. Okay? What is the second most important thing you worry about as a .NET developer? Memory. What's the third most important thing you think about as a .NET developer? Have you guessed? It's memory. Memory, memory, memory. That's all you care about as a .NET developer. And all the problems you have in your .NET applications revolve around memory. And it's the case where you have memory leaks. You didn't think you could have memory leaks in .NET, did you? Well, let me show you one. So I wrote a little test app here called Out of Memory. So I'll run that app, right? It's nothing too exciting. But let me show you what a memory leak looks like in .NET. Some of you have seen this, but this is the first thing I want to demo, is how do you keep an eye on this kind of stuff? The number one thing that you should always be running in all your test environments, all your production environments, is perfmon. Because perfmon, there are performance counters in here that will help you see exactly what's going on in your application. So I'll maximize this window out. We've got our performance monitor here, right? Some of you have looked at this before. But what do we want to really concentrate on here? Well, let's get rid of the processor time because we don't care about that. We care about our memory, right? So what I'm going to do is I'm going to go look for the performance counters in the .NET memory section of the performance counter perfmon. And what I'm looking for here is OOM. So I want to concentrate on my process name here of OOM, and I want to watch the number of bytes in all heaps. That tells you the size of the garbage collected heap that you're dealing with. Kind of want to keep an eye on some other things, right? Generation 2. Right, because .NET works in a generational garbage collected system, and what that means, very briefly, to learn more about this, go read Richter's CLR via C#. That's Jeffrey Richter's CLR via C#, 3rd edition. His discussion of garbage collection will get you up to speed on the garbage collector. But for those of you that haven't read the book, basically what the generations are, generations allow the garbage collector to run faster. Generation 0 is basically the size of the CPU cache. Generation 1 is a little bit bigger, but it's got a very high locality of reference in RAM. So, it's like memory is around like memory. Like objects are around like objects. Generation 2 is everything else. So what happens when you've got a .NET memory leak, Generation 0 is kind of very short-lived stuff, and your app runs and everything. Eventually, Gen 0 fills up, so it has to promote those objects that still have references up to Generation 1, right? So what eventually happens, your application runs, cleans up Generation 0 a bunch of times, then you go off and you run and you fill up Generation 1, it has to promote to Generation 2. And when do Generation 2 garbage collections run? Never. right? In the big scheme of things, Gen 2 garbage collections never actually run. When you think about actual computer time, the nanoseconds and all of this kind of stuff, so you have this situation where you want to keep an eye on the number of Gen 2 collections, right? Just to see how many are rolling on. You want to keep an eye also on the Gen 2 heap size. That tells you how much memory that you are pushing up to this essentially never collected memory. Now, Gen 2 is not evil. I want to be very clear. It's not evil. However, it's something you want to keep an eye on, because the whole point of this talk is, your memory leak is where somebody is referencing an object you didn't expect. Right? Somebody's holding on to it, so it can't be garbage collected. That means it got moved up to Gen 2. So we'll keep an eye on the Gen 2 heap. And we'll take a look at a couple others here. We'll look at the process memory as well, because this is just the overall information. So I'm just scrolling down here. If one of you want to write a better perfmon, you'd make $1 million. So let's go look at our process memory here, our process information. I want to keep OOM there. And I kind of want to look at just my overall memory. This includes native memory and .NET memory. And these are just good performance counters to keep an eye on. Let me go find the private bytes. Okay. Always want to keep an eye on your private bytes, so we'll add that. And we will want to keep an eye on working set. Okay, so let me describe what these two are and why they're so important. I guess we could show the description of the private bytes. The description is not that important or not that obvious, but it's probably the most important performance counter on your computer, because what the private bytes are. Oops, I got them for total. I didn't get I didn't get OOM. So let's get the correct one here. And OOM, get that one added. But the private bytes, those are the all-important memory counter that describe how much memory your app is allocating in total, right? Because .NET memory is a subset of the native memory. And so by keeping an eye on these two performance counters, you're also accounting for native code, and it just kind of gives you your overall memory usage for your allocations in the private bytes. Your working set, on the other hand, as you can read at the bottom of the screen, that's your how much memory your application needs to turn over at that particular instance in time. So it's just kind of, that's what Task Manager shows you, is your working set size when you're looking at that, and Process Explorer from sysinternals as well. But these are just good numbers to know. But these counters that I've added here, you all should be looking at these constantly, because the memory problems in .NET sneak up on you. Right? And I debug a lot of applications for a lot of different companies around the world, and it all comes down to memory. And one of the first questions we ask is, when did you notice it was a problem? Well, they notice when it's a problem in production. Okay? And that's the problem. You need to kind of notice that, hey, as we add more things to the code, we've always kind of stayed around this particular level. All of a sudden it spikes up. Hey, now you've got, you know what normal is, right? Half the battle in debugging these .NET problems is figuring out what's normal. So you should be monitoring this constantly, because then you'll know normal. Then you'll know, wait a minute, this is kind of going up, and we've never seen it go that high before. It's 20% higher than we've ever seen it. So I've added these performance counters here, and we can keep an eye on them here. So I'm going to set the y-axis here. Let's go to the properties. I want to get the properties set a little bit better. Let's set our vertical scale to 10,000, so it's a little more reasonable. 3, and so we can see a little better information. So this little out-of-memory application is running, and this is kind of boring. Let's take a look at the question here. There you go. Yeah, you do one. So it's great when I answer the questions before I even read them. So good stuff. Okay. How many managed heaps does a .NET process hold? It depends. This is actually a pretty good question. It depends on if you're using workstation heaps or server heaps. Okay, if you're doing an ASP.NET application or a service application, anything that's a service-based type application, the heaps are server-based. Okay, what that means: one heap per CPU. So, like, I'm on a laptop right now that has dual core. If I was running an ASP.NET application or a Windows service, I would have 2 managed heaps in your application. The only reason this comes really into play is when you start looking at production problems with WinDebug and SOS. And so that way I'll talk, we're going to see a little bit of this because we're going to look at references with this. But the idea here is the number of bytes in all heaps, that accounts for all the managed heaps, okay? But, you know, that's why service applications have a bigger memory footprint because they trade space to avoid synchronization. Where workstation heaps, that means one heap for all the CPUs in the system. Okay, so they trade space, they trade synchronization for lower space, thinking that most server applications servers have more memory than systems. Okay. Oops. Yeah, I dismissed the question, so I know multiple app contexts, Mark, the heaps are all shared, so you can actually have multiple app domains, but they still do the one heap per CPU. So don't worry about the context and things like that, because under the hood, they kind of share everything. And that's all to avoid synchronization. Okay. So let's allocate some memory here. Now that we've kind of got our baseline here, let's do a little bit of work in our application. And what do you see here? You know, probably the most important one here, let's bold this guy, highlight that, Gen 2 heap size. Let's keep going a little bit. Number of bytes in all heap is pretty big as well. But you notice that the private bytes started jumping up, okay? Because, you know, there's more, you know, the .NET memory is a superset. Let's just keep allocating memory. Okay, and kind of look at you know, some of this information about, you know, our working set's going up. We see the number of bytes in all heap has gone up a little bit. We'll just keep allocating memory. But, you know, I just wanted to kind of show you some examples here of you know, let's get our private bytes and working set. Right, you can see, you know, this application, especially its private bytes, is just stair-stepping up. Okay, this application has a memory leak. Okay, and I just wanted to show this so you could see kind of an idea. The stuff built right into Windows, you can get some pretty good information, and you should have these on your test systems, especially. This is part of your test runs, so that you can figure out what that normal is. And you know what eventually happens if you allocate enough memory. Okay, I don't know if you've ever seen this before. This might be new to some of you, but my application just ran out of memory. Because this application, I just allocate a bunch of memory, and it eventually dies. Okay, so this is what happens when you eventually when you have a memory leak in .NET. You know, and the more memory, you know, it all comes down to small memory. The less you use, the faster you're going to run. Okay, but if you do it bad, like this application, you eventually crash. Okay, so you know, we've got somebody referencing these objects. We've got a memory leak. Okay, and by looking at those performance counters, we get a pretty good idea very quickly, kind of, you know, hey, what's going on with our memory? Now, here's the big, nasty problem in the .NET world. How do you figure out who's referencing your objects? Okay. Well, I got good news and I got bad news. Okay. The bad news. What's the tool you all use to debug your applications? Visual Studio. It's an outstanding debugger. But looking at an object in Visual Studio, can you tell me what object is referencing something that you're looking at from Visual Studio? No. That is not a failing of Visual Studio. Patrick Dessud and those guys who designed the garbage collector, they said, hey, we need to be able to sit and look at this code, and we don't want anybody thinking about the garbage collector. We want to treat it as a black box. And one of the problems is that they don't expose that information. So we've got, you know, you could look for it in code, but it can take you forever. I mean, literally forever. So we've got a little bit of a problem, okay? Because Visual Studio doesn't give us reference trees, doesn't tell you what generation an object is in. So, you know, that's not a real good thing, right? And, you know, so you're going to have these production problems on the production server, and you're not going to have an easy way to debug them. So that's the bad news. Okay? Okay. Go ahead and take care of that one, Brian, if you can. Justin's problem there about the audio. He'll get you straightened out. But let me just double check that the audio was working there. So I know I'm still working, still talking here. So we got to figure out who's referencing an object. Now, here's the good news about figuring that out. We do have ways of doing it. But you kind of go into the realm of the hardcore very, very quickly. Okay? So One way you can figure it out, some of you have been around the .NET world enough, you probably have heard about the native Windows debugger called WinDBG, which is part of the debugging tools for Windows, and an extension called SOS. Okay, so we can do that, right? You know, like let's take a look at a program. Let's get my program up here. So this is a real simple .NET program that fits completely on the screen, okay? So I want you to look very, very closely at this code. I'll give you a few, look at it as I'm talking about it. But I'm going to run this program here in a second, but you kind of see what the code does. It fires up a timer. It sets the timer to null. Then it calls gc.collect. And guess what? We wait for pending finalizers, and we stop on a console.read line, okay? So let's go look at the funny timer code a little bit here. You see, we fire up your standard timers in .NET. We have set up an event handler, and we do the elapsed event handler, right? Nothing too exciting, right? Very, very simple stuff. And you see that all the elapsed timer method does, the t-elapsed method down here, what does that do? It just writes out the date time. So now think through what you think this program would do. Okay? You'd see it run. Well, hey, wait a minute. It's going to run. We're going to trigger it. We're going to do it every second. It will come through. It will do a date time. Then we set it to null. Then we collect it. We force a garbage collect in. So we should only see the output of one elapsed timer execution. So let me execute that program. Oh, is that what you expected? Okay. So, I'll just press Control-C and break the program. That's probably not the output you expected, was it? Let's go back and look at the program. And this is a little bit of a contrived program, but it's the smallest program I could come up with that shows exactly the issue that you have on your production servers in a screenshot of code that you could see. So what you're looking at here is that somebody's got a reference that we can't see, okay? That's not obvious from looking at the code. So somebody is obviously holding on to this funny timer, okay? So how can we debug this, right? We could go take a mini dump of it. I'll cheat a little bit, and I'm going to use WinDebug, the debugging tools for Windows, and I'll just do a file open executable, because you can debug this all day long. You don't debug your .NET code with this. We're just using this to load the SOS extension. So, let me get the program loaded. Demos.NET debug. And to learn more about WinDebug, I've written books about it, but probably the best, if you've never seen WinDebug and SOS before, let me recommend a book. It's called Advanced .NET Debugging by Mario Hewart. It's a little hardcore. It's a lot hardcore, but Mario does a good job getting you up to speed on it. So let's go run this program here, and there's our timer, right? It's doing the same thing as we had before. So what we're going to do here is I'm going to show you the hardcore way to go figure out your memory references. So what we're going to do here is you see that somebody's holding on to that reference. So let's do our .load by SOS CLR, and CLR is the module, the DLL, that's the core runtime DLL. So I've loaded the SOS extension here, and let's go look at our types. Well, we can look at the types here by seeing the types that are in the code. Okay, let's get the question. Okay, even that's a fine question, no problem there. Let me get you set up here. I should have done that. I didn't. Okay. And the book is Advanced .NET Debugging. It's this book here. It's the most recent book on WinDebug and SOS. So thank you very much for asking that question. It's a good question. Okay. It is hardcore. It is hardcore, Mario. You do a bunch of good stuff in there. And this is fun. This is Mario's book. And Mario is attending the talk. Why, I don't know, because he could give the talk. But he does a very good job of bringing you up from no Windy Bug knowledge through really develop and dealing with production problems. So Mario's got, it's kind of fun to have Mario in the class. So Mario can answer questions for you. So set up a private chat with him. But anyway, it's a very good book. Really gets you up to speed on things. So I've got SOS loaded, and what I want to do now is, let me get back here, and, how do you know what types you're looking for? Well, that's the types you define, and what SOS knows how to do is to dig into the garbage collected heap and find this information. So a lot of people ask, well, what is SOS really doing? Well, back when they were developing the garbage collector, which is all written in native code, by the way, there's no .NET in there because it would cause a lot of problems if you're garbage collecting as you're writing, you're running .NET code as you're garbage collecting. So it's all written in native code, and they needed a way to debug the garbage collector. So they wrote this thing called Strike that allowed them to debug the garbage collector. Well, many people found that pretty useful looking for memory references, right? What the hell's going on? So what they did is they built version 2 of it, and it ships with the .NET framework. So you got, all of you listening to me are looking at this on your machines, right? You have it on your machines. And so this extension, they built version 2 of it, and to be funny, they called it Son of Strike. That's how it got its name, SOS. So what we've got here is I've loaded the SOS extension, and the command I want to run is dump heap -type, and I want to do that funny timer. Because obviously, if you go back and look at this tiny little code snippet, you can see that somebody has this funny timer still referenced, right? It should be fairly obvious from the code. So what we want to do here is, now that we've dumped that out, this has given us the address of that object. So we've got the address of the object, and we can use other commands in here to go look at this. But we've got a little bit of an issue. Okay, if you do bang help, this will show you the help for SOS, and that's the command for the help. There's not really a command that directly shows you the references in a clean way. Okay, we'll talk about some other commands that this does here in a little bit. But one of the problems you have is that we don't have a direct way that says, give me all the references. Okay, so there's another extension that a lot of us use, and this is also covered in Mario's book. It's you can get it. Here's the URL, stevestechspot.com, and the extension is called, the official name, according to Steve Johnson, the guy who wrote it, is SOSEX, but I like to pronounce it SOSEX, because I just like saying the word sex in front of a whole bunch of different people. So SOSEX is an extension that can be used in conjunction with SOS that allows us to go look at, and it's got better commands. So you use this side by side with them. So, we could go find this information with SOS, but we would have to do an incredible amount of work. Okay, so if you're paid by the hour and you're a consultant, it's the ultimate, right? Because it'll take you. It would take me probably about 8 hours to go find all the references for this thing using just pure SOS commands. And like I said, you can debug yourself a new minivan, a new car, maybe even a new Porsche, because it's going to take you so long to deal with this. So I'm going to load SOSEX. Well, Nilesh, the dump heap -stat just kind of shows you the overall picture, but I want to concentrate on finding the one reference chain. So read Mario's book about dealing with, dump heap -stat and some of these other commands in there that really help you out. But I really wanted to concentrate on the references on this. Dump heap -stat shows you the number of objects and the amount of memory that they're taking up. So let's load SOSEX here, and right, we've got it loaded. Well, one thing that SOSEX has is a refs command, okay? And the refs command here can tell you reference chains, okay? But let's take a look at this, okay? I just cleared the screen, by the way, with a .cos if you're following along at home. So what I'm going to do here is I'm going to do bang refs on that same address. I just pasted it in so we can take a look at it. So here we go. And now what we're looking at here is these are the child objects. These are the parent objects. Okay? So does everybody kind of see how this display works? Think of it as like, if you've ever used the Visual Studio's call tree view, it's kind of like that butterfly view. You know, these are the children, these are the parents. So if I want to walk up the reference chain, what do I get to do? Oops, I meant to press Control-C. Bang refs. Okay. I pasted in the wrong address here. Yeah, sorry about that, guys. I grabbed the wrong address. This is the fun of, okay. And you see, I'm just walking up the reference chain. Okay. And what we eventually get back to here is that we're kind of getting back into some native code, basically. But, you know, this looks very painful, right? And I did kind of want to show you this. You could find this, if these were the only tools you had, you could grind through here and make this happen. Okay? That's about what that was what I was going to introduce next, Sebastian. But we're working our way through from hardest way to do it to the easiest way to do it. So, you know, this is, you know, I just wanted to show you the really hardest way. But the important takeaway from this, the information is there. Okay? And there are ways to get at it. And Sebastian kind of gave away my little secret, no big deal. But there's other ways to look at this as well that are a little bit easier. But so let's go concentrate on looking at those. And I'm going to run a different program here that, you know, just is a little bit more than the simple program. But I want to turn to another command that is incredibly helpful in SOS called gcroot. So what we're going to do is I'll run Windybug again, and we'll open up a different program. And unfortunately, because we're over live meeting, this won't demo that well. But what I did is I was on a plane, and you know, I always loved those programs that would show you algorithm sorting. Right? These things always fascinated me when I was learning computer science in university. So I just wrote a program called Animated Algorithm that, you know, dumps out a bunch of different, you know, allows you to sort different ways and kind of see how the shape of the array goes. You know, just your standard thing. You've all seen these things before. But what I want to do now is I want to turn to, we'll break in here. Let's get, if you do the right command, it works better, .load by, sorry. .load by SOSCLR, get that in there. And kind of what I want to dig in now is I want to see using that gcroot, right? So the command we want to use is a different command called gcroot. Now, the reason I pulled the help up here is I want you to look very, very hard at what gcroot does for you, okay? It's looking through the garbage collected heap. If it is referenced on the stack within a GC handle table, it is an object ready for finalization, or is a member of an object found in 1, 2, or 3 above. Okay? I want you to think hard about this. So gcroot does a very good job. Like Sebastian said, it does. It's 99% of the time, it's very, very helpful. But I want you to think hard about this, okay? Because what do you think is missing here? Okay? Or you could potentially miss with this. What about a static reference? Okay? It's possible that this might miss static references. This will get almost all of them. This is a 95% plus useful tool. But there are cases where this can miss a few of these reference chains. Okay? But in the general case, this is a very, very fine command to use. So what I want to do is let's do that dump heap, and let's do dash type again, and I want to look up a particular type, and dump heap dash type allows us to look up, based on a string contains operation, you know, I wanted to look up my animated algorithm form. It's just a simple Windows Forms application. Let's clear the screen. And what I can do with gcroot is I could dump this out, but look at the reference chain now. Okay. So it does warn you, you can have false positives with this as well, because think about how the stack works on a computer. You can have a spot on the stack that has garbage in it that was there before, so it's possible to have false positives. I also should explain the GC handle table. The GC handle table is a thing used internally by the .NET runtime that says, hey, you're doing a P invoke, and think about the worst thing that could happen in a .NET application. You pass over a delegate, right? What's a delegate? That's a function pointer in C terms, C and C++ terms. You take a delegate and pass it over to a native API that requires a pointer to a function, a callback. That native code holds on to that pointer that you passed in so it can call it back. Well, your application continues to run and you lose the reference to that delegate. What could happen to it? Well, it could be garbage collected. Then 20 minutes later, the native code calls your delegate, and what's going to happen? You're going to crash in completely different ways every time, and it would be very hard to debug this. So like what they do when you do P invokes is that they help you by wrapping a reference on those objects you pass over to native code. And that's basically what the GC handle table is. It's a little more detailed than that, but that's basically how you would use it, how it gets used in most of your applications, because they want to control exactly how you don't lose that reference, because at least they have a reference to it in the framework. And yes, it handles it if it's a long-lived object, and then the native code, they do all the right things in those cases. Okay. But you can see from this output, man, this is great, right? It's looking on the stack. I'm on a 64-bit machine, so we're looking at RSI, RSP, R8, or R15, all of that. And this makes it very easy to look at reference chains, because we have our root, and the root object is this the application. The plus sign here, that means nested class. So inside the application class is a nested class called threadContext, which has a reference to the animated algorithm.form. Okay? And so you can see it's a direct reference from this thread context, because animated algorithm is written to be a good multi-threading program. So it does the sorting on the background thread, but the UI update on the foreground thread. That's why we've got these thread contexts around. Now, as I scroll through here, we'll find some bigger ones. Like here's a big one. We've got some object array. By the way, this backtick 2 indicates a generic. That's how they show generics in this kind of scenario. So we've got some kind of, plus having the namespace generic helps you out. So some object array has a reference to a dictionary, which has a reference to a dictionary entry. That's a nested class, which is a reference to a list, which is a reference to another object array, which goes through a system events through a nested class called system event invoke info through user preference change handler, and that has a reference to our form. So you can see from this that it's just walking up the reference chain. That's pretty excellent, right? Because we've got this great way of looking at our code so that we can see exactly what's going on. And so now GC root is most of the time it does a pretty good job, okay? So GC root is very, very helpful once you find your object, who's got a reference to this thing, okay? And that's what GC root gives us. But this is a very simple example here that you guys can all see, but you guys are dealing with things that are a lot more complicated than this. Let me get the question here. Oh, what number in these says how much memory is consumed? In the output of GC root, none. None of these numbers say how much memory is being consumed by that object. Okay. Now there is an SOS command here, Mark, that I'll go ahead and do it. If I wanted to see how much memory this object, this animated algorithm form, is responsible for holding on to, I can always use obj size, and then that will walk all the child objects, grandchild objects, great-grandchildren, and so on. So this is saying obj size says this object is responsible for referencing 27,008 bytes. So if you wanted to see reference chains, what you would have to do to see object sizes, you'd have to take, for example, this very last one here. This is the object you want to get the reference on, and so that's walking up the chain and how it's got a reference to it. So So you would see how much memory this object and everything it references is pulling in. So, and that's a very common question, because you're like, okay, I've got 4,000 of these things. Which one's the big one? You're going to have to do a little bit of work to get that. Not really, Ivan, because it's kind of an edge condition. I just wanted to make you aware of it, that it's not the true view of all the output. Okay, because what happens is that probably 2 of you on this webinar will go run into this problem. It's pretty rare, but it does happen. But I'm going to show you other tools that solve this problem. How's that? Okay, that way it makes it a little bit easier. But it's the GC root in the general case, in the 90% case, 95% case, it's just fine. Okay, there's some odd edge conditions in it that it just won't catch. But I'm going to show you tools that catch everything. Okay. Possibly, Mark. It's a remember. Let's look at that output of the help again. And you can see if it's a member of an object found in 1, 2, or 3, right? So in most cases, if the object is on the stack that has a static, it'll get found. Okay, don't get wrapped up on this. Okay, this isn't a death thing. It's just something that we need to mention about GC root. That is not. It is not the 100% solution. It's the 95% solution. So for most of you, it'll never be a problem. But there are some cases where you can get into some situations where it just doesn't catch it, because it's not looking at across statics. As we go through this presentation, like I said, I'll show you a tool that gets in there and does that. Okay, so that's kind of nice. So, but let me go back and clear the screen here and dump all of this out. This is when you're looking through, tens of thousands of lines, this gets really old, doesn't it? Okay. Wouldn't it be nice to visualize this? Well, it turns out, if you go to Levitt Software, actually, if you just Bing for, hey, notice how I use Bing instead of Google, but I am using Google Chrome. Anyway, if you just search for visualizing runtime object graphs, you're going to get to Chris Lovett's website. Chris Lovett is an architect on the Architect edition of Visual Studio. And he's one of the guys that designed a thing called DGML, which unfortunately a lot of you haven't played with. But let me show you how this works. So you can download his tool, his nice little tool. I've got it in my util directory. I use this all the time. And it's called GC Roots to DGML. It's just an executable, just a console application. It comes with full source code. That's an open source project. But what you do is, let me take all of this output from GC root, and I'm going to save it to a file. Okay. And so we're just saving that output to a file. That's all it is. It's just a text file, nothing too surprising. But now let me run his tool, okay? And DGML. Ooh, that was exciting. In fact, I should probably change to the junk directory. Hey, we produced a DGML file. I know you guys are all excited and are just really want to deal with this. How do you look at a DGML file? It's called Visual Studio. Okay. So let me get Visual Studio fired up here. And all we need to do, if Visual Studio would fire up, is just do a file, open file, and open up my DGML file. And I did the Alt-Shift-Enter to get it at full screen. And what are you looking at? A whole heck of a lot easier way to look at that output. Okay, and it's kind of nice because you can add node properties, category properties, and things like that. You can highlight trees down. So if you need to look at that DGML output, you kind of have the like I said, the 95-96% case. This is going to do what you want. So this way you have a way to visualize those object graphs, and it does all the work to coordinate them all together. So you see, hey, this object is probably something I want to take a look at. Okay, but let's show. But you kind of see a little bit of the problem here is that what object is that? Okay, that's the problem. We see that we've got an object there, but it's not everything. Yes, right, Mark. It just has one entry. You're exactly right. It has one entry in the hash table and one in the dictionary. So that's exactly what you're seeing through this. Now, we could have picked that out from the raw text, but this makes it look a little. Actually, let me back up here. We have one reference chain, and I'm moving the mouse down the first one, and then we have a second reference chain where the hash table has a reference mainly to the application thread context, which has a reference to the animated algorithm. Then we've got another reference through the dictionary down through a user preference chain event handler to the animated algorithm form. And remember, the bottom thing here, the animated algorithm form, that's the thing I was taking a look at, okay? But you can see there I got the pop-up. Sometimes that pop-up's a little tough to get. But you kind of see the frustration with this because, in a lot of cases, what you want to do is you want to see, well, wait a minute, I know that's my object, the animated algorithm form tooltip I have up there. What I really want to see is one of these guys up here. I want to see its object, so I can go look its object address, so I can go look at that. So it is open source, but I got some good news for you. Okay, so let's keep that running there. There's my view. Let's take a look at something else. One of the people that took advantage of Chris Levitt's software is Mohammed El-Gesh, a developer at Microsoft, and he created a Windybug extension called Visual GC Root. Okay, so this is an extension that loads into Windybug. Okay, so at any time, let me get this loaded. Make sure I got the right one. Where did I? I forgot where I put it. Well, I'll download it. I forgot where I put it on my machine. He's got a 32-bit and 64-bit version. Let's get. I apologize. I thought I had this down. I thought I had it in my util directory already. So we'll just copy that to my junk directory. There we go. Junk. I'll get it here. Okay. And just to verify that got loaded, there we go. Now, what's nice about this, okay, is there's a lot of options to the GC root, and you can get to the help here. So what we could do is that this is a drop-in replacement for the GC root command, but what it does, instead of producing all that text output, it produces the DGML file directly. So what I can do with this is that we can go back here and let's get my object address. There we go. And what I want to do is I want to add all the options to it. We can have it do a dump obs. We can have it do the fields, and we'll let that go. And I'll do. Okay. So that created the DGML directly, and you all know how to open that up. And I've done the same object we did before. But let's get this expanded out, and you get a whole bunch. You get a whole bunch more information because, in essence, on every one of these objects, it runs the SOS command abang-do, and so you get to see the individual fields that are dumping these objects out. And so it's really the way you want to go. And they've got this for 32-bit and 64-bit. So by using this VGC route, you get a pretty nice way to visualize your objects directly. So you can look at all sorts of different properties on here. Let me see the domain on everybody. Let me add other node properties that we might get. Root type, which which everybody is. But the fact is that now we can see the complete detail of all of these objects. So in many, many cases, this has worked out just great for me. If I'm looking for an individual type, right, just VGC root code, show me everything that I've got going on, so I can see what's going on in there. And hey, it's real easy because we're just going to open up the DGML directly in Visual Studio. The other thing that's nice about this is, since it is a WinDbg extension, what you can do with it is you can get really serious about it and script your kind of common operations with this, because you can use your standard WinDbg scripts, because you can run WinDbg with the -C command line option, do $$ less than, and that will read in a text file and execute the script. So I do that sometimes, if we're looking for the same object types over and over and over again. So I just wanted to show you that you can get at this information very easily. Okay? So let's get the question here. No, I should back up. Yes, it does, ZD. It requires a version of Visual Studio that can read DGML. And I'm using Visual Studio Ultimate here. I don't know where, to be honest with you, I don't know where the DGML reading doesn't come into play. It is somewhere up on Microsoft's site. But it does require, it may be a premium edition, because in fact, I'm pretty sure if you have just the premium edition, that can read DGML, but you can't edit the DGML like you can in Ultimate. The Express versions, I know for a fact, don't have it, but premium, I think, is probably the lowest level that needs that. Okay, and it seems like most people have that, so you should be good. So I just wanted to kind of walk you through. Hey, you can find this information. And you can do it, but it's kind of hardcore, isn't it? And there's that tiny chance that you may miss a static in just the right way. Well, let's look at the last tool, and instead of grinding through the tool, I thought I'd do something interesting. I wanted to talk about a commercial tool here, and that commercial tool has got the greatest website name in the world, memprofiler.com. Okay. This is a tool. This is a commercial tool, and basically what this tool does is everything we just walked through manually does it all automatically. And if you buy the professional edition, it does full, complete mini dump analysis. It takes several hours to open up those mini dumps, but that was the scenario that you generally need for these production kind of problems. So I do also want to issue a disclaimer here. Scitech has never given me the tool. I have paid my own money for this. Okay, this is what we use a lot at WinElect for these kind of memory reference problems. So what I thought I would do for the last few minutes here, I'll stay until all questions are gone. What I thought I'd do is something kind of interesting. A customer gave me let me share with you a bug. So here's the scenario. Let me hide this first. Let me describe the bug. So I got a client in New Zealand calls up and says, we've got a memory problem in .NET. We have a big WPF application. The private bytes never go down. The .NET heap sizes never go down. They just go up and up and up and up and up until we run out of memory. Basically what I showed you at the beginning of the talk. Okay? I said, do you have any mini dumps of this? And they said, yes, we've got a mini dump of it. We've got it on our FTP site. You can grab it. So I download the mini dump. Okay, so that's all I know. It's a big WPF application, and it's leaking memory. Okay, so what's the first thing you do? Okay, well, let's take a look. This is the actual files with some names marked out that I sent to the client. I use OneNote for all my debugging. So what I did here is I opened it up in WinDbg first. I wanted to get an idea of kind of where the problem was. So I opened it up in WinDbg and took a quick look, and I checked the versions. Now, this was using the .NET 2 version, so it used MS Core WKS was the name of the main .NET assembly in those days for .NET 2. So the first thing I wanted to do, I think it was Nilish that mentioned this. It's a very, very good command. Obviously, we've got a ton of stuff in memory. What is it? What has got the biggest things in it? So I used bang dump heap dash stat. What's the big stuff? And this is a truncated version of the output. And you can see in this output, we see this dump heap dash stat is a wonderful command because it shows you the number of objects in this column, and it shows you the total memory sizes of that particular type that you're looking at. So this is the bottom of that output. I didn't include all of it in here because it was a huge app and it just went on for a long time. But something very interesting jumps right out, okay? We've got this effective value entry array that's eating up all the memory. You can see that it's using, what, 136 million bytes, right? Versus the next closest chunk of size object is an object array that's just about half that size. So obviously what's leaking in this application is the effective value entry array, okay? Does anybody know what an effective value entry array is? Okay. I didn't know what it is. That's why we have Bing and Google. So I did a quick search. I was like, system.windows.effective value entry. That sounds like something coming out of the framework. And I did a quick a web search. It says effective value entries are for event handlers in WPF. Okay. So what's my total time investment that I could charge the client? So far, my total time investment in this entire operation, because I can't charge them for downloading the mini dump, total time investment, 63 seconds. Okay. So I'm billing them for those 63 seconds. And what we've got here is we've got our big hint. This is what, obviously, somebody is holding on to these. Now, if the client was willing to pay for it, I could do this by hand using VGC root and some of the other things I showed you. But you can see there's a lot of them, right? There's almost 70,000 of these things floating around. We got a little bit of a problem here. I don't have that kind of time. The client's not going to pay me for it. So now it was time to call out the SciTech.net memory profiler. So I took this mini dump and I loaded it into the SciTech.net memory profiler. Okay, and what we're looking at here is screenshots from the SciTech tool. And the SciTech tool has some error checking in it and some analysis in it. And it basically right off the bat says you got a problem with event handlers. Simple enough. So we had to find out now what's this is the effective value entries of the thing. I need to walk up the reference chains, much like what GC root gives us. But I want to make sure I catch everything, and I want to get some representative stacks. So I open it up, and sure enough, it's telling us the exact same thing that we're seeing from SOS. Got some problem with their event handlers. This is the information that the SciTech tool gives us. Okay, so now I'm up to 66 seconds that I can build them with. Sure enough, I said, okay, we got a problem with the event handling. What I need to do is walk up the view. So what I did is I took advantage of what SciTech gives us. It is now this view has been improved. I'm using version 3 of the tool to show you here. Version 4 is all graphical, much like DGML output. It's a lot easier to look at. They've changed this view completely. But this was enough for me to pinpoint the problem. So what I did is I went to the view in here that says look for a particular type, look for that effective value entry, and I want to walk up the reference chain. That's what those up arrows mean. Here you see it going up and up and up. So I highlight an effective value entry, and I kept clicking up, and I kept clicking up, clicking up, and what am I looking at? A property changed event handler. Okay? And I took a look, maybe another 20, 30 seconds at a couple of different of these effective value entry arrays, because the SciTech tool will show you individual ones, and I just took a random sample. Almost every reference chain looked exactly like this. So what's the memory leak here? They had a plus equal that signed up for a property changed event handler. They never had a minus equal. Right? If you got a plus equal, you better have a minus equal. And so literally in about 2 minutes, right? It really is about 20 minutes overall for everything by the time I put it in the report and called them. So in 20 minutes, I found their memory leak. And so at the end of the day, you know, for simple stuff, your day-to-day work, you can use VGC root easily. But when you're looking for the real production problems, you're going to turn to the SciTech tool. Now, the SciTech tool does much, much more than what I've shown here. But I wanted to just kind of guide you through looking at some of the easy ways, the free ways to do things. And when it really comes down to it, you spend the money on the SciTech tool, and that way you can find things. Other tools out there can help you, or the Redgate tools. Those are great tools as well. But for this particular bug, I was able to use the SciTech tool. Okay. Yeah, sorry about the DGML thing. It's Brian's jumping in and letting me know. I think he's looking that up in the background. But I'm pretty sure reading of DGML is available in lower, because I remember there was a big debate inside Microsoft about this. But it's writing DGML is only in Ultimate, so I'm fairly sure about that. In essence, yes, Mark, it's much the same error, but it's just on a much, much bigger scale. And this is a real-world example. But that timer example, again, it was an event handler leak. That's really, at the end of the day, what it was. But, you know, I wanted to show you a bigger real-world example here that you could see. So what I hope to show you in this hour is how you can use free tools to look at your stuff today, and also why you may want to look at a commercial tool. Okay, I didn't want to make this whole thing an hour-long. Let's sell everybody SciTech. It's just a tool I use and a tool I love, because it makes finding these kind of reference problems easier. But I've looked at plenty of reference problems in my day-to-day development with WindyBug and VGC root, GC root itself, just so we can get an idea of what's going on. And, so I hope I was able to show you the different ways of looking at these kind of scenarios that you run into on a day-to-day basis. Two things I want to leave you with. Number one is my email address, and I put the wrong one in. I don't want you to send a mail to my Microsoft account, because that's for other things. That was a mistake on my part. I apologize. Mario, who works at Microsoft, can send me email, but the rest of you can't. Sorry. So if you have any questions between now and the end of time, right, because you're going to go play with this stuff and get lost a little bit, go send me email, john@wintellect.com. I work with a bunch of brilliant people at Wintellect. I'm very, very lucky to work there. If I don't know the answer, somebody at Wintellect does. So we'll be happy to take your questions to figure out things. Okay? And I will also stick around and answer questions until everybody is done. And I hope I was able to... Eugene, I've had very good luck with the ANTS profiler, the Redgate profiler. I've used that. Now, I like the ANTS profiler more in my day-to-day development, but check out version 7. They've improved the UI quite a bit with the Redgate tools. I use it. You can see it's on my machine. When I type mem profiler, oops. I use the ANTS profiler. I found version 7 to be much better. They did a good job improving the UI. But I think there's I've solved production problems, and people have hired me, and I've used the Redgate tool to deal with it. I just think that especially the fact that the SciTech tool can open up mini dumps. And when those production problems, that's where I find the SciTech tool to be very good. The Redgate tool, I like to use that one. I find very useful in my day-to-day development. So I use them both, right? And I use the Visual Studio tools as well, because I want to use the best tool for the best job. Okay? The last problem with WindyBug, Tim, was what I did was with this one here. I was just showing you the GC root. Is that I think that was the problem you're asking. The problem is with GC root, you get all of this kind of output that's really hard to read through. The main thing I wanted to show you is that you could get a visual representation of the reference chains with VGC root. So I didn't really use heapstat-ui at all for that. Okay. 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 Oh. Oh, the real world problem. Okay, yeah. It's no problem there. Let me get back at that. What I did with this guy here is what I did to get a quick idea, because this was using a ton of memory, right? It was just going up and up and up and never releasing any memory. So what I used was dump heap -stat. And that allows, this is a wonderful command because it shows you the sorted by largest, most memory used for a particular object. So my big hint here was the dump heap-stats simply told me I've got this effective value entry that is bigger, that there's more of those than anything else. And that was the big hint because I did a quick Bing, Google search, web search. What is an effective value entry? It's an event handler hookup down inside WPF. So that's where it pointed me in the right direction to look. So that told me, wait a minute, I've got this dump. I've got 70,000 of these. I don't want to look through all of these by hand. This is a perfect application of the SciTech tool because I need to go figure out how my client is sitting in here referencing all of these chains here, and that's with this view. Now, they've got a much better view in their version 4 product, but this tells me there's my effective value entry down there, and I walk up the chain to my client's code, and that's what these high black items are. So I took their types away. So that's the big hint, is I just needed to see what there was more of than anything else. And in most cases, that's all you need to see. Hey. Brian, this is a great question. Well, first, let me, because it's going to take a while to answer this. Umair, yes, it is. It'll be on the LIDNUG site, LIDNUG.org. This recording will be up there probably within a day or so you can review this recording later, and it will be up there permanently. So if you want to give it out to friends and so on. So let me go back to Brian's question. Beginning debugging and profiling. Well, of course, probably the best way to start is to hire Wintellect to give you our phenomenal .NET debugging and profiling classes. Okay, my marketing director is on the line, would probably kill me if I didn't mention that. But that's the quickest, honestly, that's the fastest way to get up to speed. And we do offer virtual classes of those. They're very reasonably priced. You can find more about it at Wintellect.com. I think Mario's book, I mentioned that earlier, is a very good reference. My book is slightly out of date because it was written for Visual Studio 2005, but it's still in print, and it was called Debugging.NET 2.0 Applications. I concentrate more on Visual Studio, and so that's a good way to get started. I think really the best way is how I learned this stuff is I sat down and wrote a bunch of tiny programs that, like, okay, let's just go allocate a ton of memory and see what it looks like in the profiler. Let's go, there are some walkthroughs on Visual Studio that will are very helpful. That I've done, even though I've been using these tools for almost 20 years. I went through and walked through like the Tailspin Toys demos for IntelliTrace and things like that. Those are actually very, very good because they show you exactly how to use the tool and how they were thinking about it in the design. So that's kind of a good way to go about it. I mean, if you have deeper questions about how to get started, just send me an email, john@wintellect.com. But off the top of my head, those are the ways to get going. Okay. What other performance counters, let me show those performance counters again. In fact, let me write them up. It's probably a little bit easier to show you. So the performance counters I use, the category is .NET COR memory. Okay, and the ones I used under there for the individual process is number of bytes in all heaps, right? That'll show you overall .NET memory usage. And the second one I like to look at for process is Gen 2 heap size. Sometimes I like to keep an eye on, there's other ones up there like how many Gen 2 collections do you have? If you're looking for kind of problems with those applications that are thrashing the garbage collector, which is kind of a rare thing, but I get those because people don't know what to do at all, and so I see those. But these are the two best general ones. Then the other category you want to look at is in the process category, and the ones you want to look at there are private bytes and a working set. Those are the 4 key performance counters. There are other ones up there that, you can go nuts watching performance counters, but those are the 4 I consistently watch on any type of application I'm developing, whether it's a console app, Windows Forms app, Silverlight app, ASP.NET services. These are the ones I pay attention to. So those are the best 4 you've got. Okay, and there's other there's a bunch of discussion on the web as to what are the others, but these are the 4 at a minimum everybody needs to look at. And that 9 times out of 10, this is all I look at. The other ones are just for more esoteric problems. But these will solve most of those kind of issues. Okay. How do we find out more information about the? Where can we find more information about the LIDNUG classes? The best place to go is http www.winselect.com, and we'll be happy to help you out with helping you with that justification. Our sales folks are real experienced, giving you ammunition to find those problems and help you get those arguments, so you can get us in and help you figure it out. Okay. Great question, Edie. Well, it depends. I use it probably a couple times a week because, remember, as I said in the beginning, it's normal, right? I really want to know what normal is for my application. So, maybe I'll run the unit tests and I'll run them under, I'll let MS Test run and let it run under one of the profilers just to get a feel for it, right? If I'm meeting my performance goals and everything's good, great. Now I get to see what I'm just getting that view. So generally about twice a week. Now, as it jumps up pretty quick if we start seeing something that it just takes a little bit of feel, I guess. But generally, like Tuesdays and Thursdays, just run it a couple of times, figure out, okay, we pump this kind of data in. This is kind of what we see. So, maybe you pump in 5,000 items, 10,000 items, 15,000 items, 20,000 items. You say, okay, my memory kind of looks like this. My overall time kind of looks like this. It kind of looks like it's going linearly. Hey, you're done, right? You're feeling pretty good. But if you start seeing that hockey stick as you go from 5,000 to 20,000 when you graph it out, that's kind of telling you that when you go to 25,000, 30,000, 50,000 items, your performance is going to degrade pretty drastically. So it's all about getting normal. So, just about twice a week, just get a feel. Maybe it takes an hour each day, max. But just get that feel. Where do things stand? Okay? Because, an ounce of prevention is worth a pound of cure. This is a great question, Milish. Let me show you how to turn on server heaps. And I will give you the one scenario where I found this to be super helpful. So if I turn them on in the, here's how you turn them on. It's real simple, okay? Because if you're building a WPF application, you have the workstation heap by default. The one time I've turned this on is I was working at a company that was building PET scanners, positronic emission tomography scanners. That's the soft tissue scanners that it can show you blood flow and other things in the medical field. And we were helping them with the application that pulled data off the machine. And so they had these custom-built boards in the server, or there's a big server class machine that pulled the data off, because this thing produced just off one image, like 20 gigs of data. I mean, just raw data. If you just streamed it raw, it's 20 gigs. Because the full big PET scanners are pretty wild. It's kind of cool to stick your hand in one and see your blood flow. They're real neat medical software. But the problem is the app that pulled the data through these custom device drivers and custom boards was a Windows Form application. And it was on an 8 CPU system. And the issue was they had a bottleneck. And they called us in. They couldn't quite figure out what was going on. And they had 32 gigs of RAM on this thing, but it was the operator's view, right? So it was a Windows Forms application. And how this application worked is it basically pulled off bands of data and then converted it into imaging, okay? And the problem was they were using the workstation heap, so they had 32 gigs of RAM with this x64 application, but they were using one heap, so they had synchronization problems like crazy, because they had the one heap and they had to synchronize across the threads. But since the data came in a band at a time, it was basically one band per CPU. That was a perfect example of turning on server heaps where the information was completely independent, could be processed separately on these 8 separate threads in the background. It massively sped up the app. It was like, 10 orders of magnitude faster. In fact, we thought we broke it the first time we ran it. But that's about the only case where I've seen they make a big difference. When you have huge background processing on background threads. So other than that, you probably shouldn't really mess with it. But that was the true classic example. Exactly, Sebastian. That's a trick that I talk about in the Visual Studio class to use gc.get generation to find out what generation an object is in. And you can do that in the immediate window, and you can call it from the watch window as well. That works just fine, but it only shows you the one object, not kind of what the generation 2 heap looks like. And now, so you can do that for that. Now, why don't the Marshall references work? The reason the marshalling methods won't work is because there is no such thing as an address in pure .NET development. That's probably not the answer you wanted to hear, but you don't have, sure, you might have the address of an object, but the expression evaluator doesn't know anything about that address. That's why those kind of methods don't work. They're, you can run it, so if you take the address from the native side, then, try to use it in the .NET side, the expression evaluator just goes, I don't know what the hell this is. So that's why those methods don't work. Okay, and it's because they hide all of that address information from the debugger. Okay, the debugger asks for it, and then it's interpreted by the CR debugging API. So they even hide addresses from the actual debugger itself. If you look at how the CR debugging API works. Okay, so yeah, so sorry about that. Yes, DLR in IronPython. I worked on a bug, and what I want you to do, Andrea, send me an email, john@wintellect.com. I'm going to have to go search. We worked on a bug for a client that was exactly this, and setting up IronPython, you can get into a situation where it will never release the Python objects. And there is an IronPython method you could call that tells it to release them, and that's the magic trick. And if you'll send me an email, because the client found it, and they shared it with me at the end, and so I can share that method call with you, because it's something you have to do during initialization of the IronPython engine. And it was quite the surprise. I have the email floating around, but it'd take me 20 minutes to go find it. So Andrea, send me this in an email. I can tell you the method that you need to call so that IronPython stops leaking memory. Okay? So we'll get you straightened out there. Brian, you're asking all the tough questions. I believe you can. I have never done it. Okay, because overall, our very, very few of our clients have done anything with CLR, so it's just never really come up. It is the same runtime inside SQL, so you could attach WinDebug and go at it, and find this. I'm pretty sure you can do it. I just haven't done it. But yeah, I do know it's the same runtime, so it shouldn't be much of a problem there. Now, if it was some kind of, if you're doing the robotics runtime or that micro.NET runtime, you're kind of on your own. But I believe all of these techniques will work with SQL CLR. Okay? Great questions. Hey, thank you, Nilesh. This was a lot of fun, man. It'd be nice if everybody was on the line, but I think these things work out pretty well. Given the number of questions we had, it's been quite fun. Okay? So cool. Any other questions? Absolutely, Brian. We've got WinTellect doing several. Brian's been great. I think Jeffrey Richter's doing a talk in August. I'm doing another one in September on breakpoints in Visual Studio, how to really maximize making the program stop exactly when you want it to stop. And I think there's a third one. Is Jeremy Wickman, or maybe Jeff Process. We just talked about this an hour ago, and I've already forgotten, but we'll be back. Tim, yes, I have. I used to work. worked at NewMega. Some of you, wow, that was a blast from the past for some of you old folks on the line. But I used to work at NewMega, and I'd been swapping mail with Russ, and I recommended Russ to get hired at NewMega after I left. So I know Russ, he did a lot of work for us at WinOak. His PE Browse Interactive, it's pretty cool. He now supports .NET debugging, so I definitely recommend it. It's another tool in your arsenal, and you can't have enough tools because you never know when that one tool shows you will be the key to solving the problem. So I keep an eye on all these tools. I do kind of Russ's tools are great, so take a look at it. It's pretty good. Yeah, Ivan will do that. We'll get those up. You can also, probably the best thing to do is to subscribe to the Wintellect overall feed. We will keep getting those up on our blogs. Bethany, our marketing director, gets those up there as well. So by subscribing to the entire Wintellect blog, you're going to get Jeremy Wickness and Jeffrey Richter, myself, and some of the business announcements from WinOak, so you know when some of these particular systems are coming through and webinars are coming through, and that way you'll get a lot of information because we're making a big effort for this fiscal year to do a ton of blogging, so you're going to see a lot more blogging coming out of WinOak. We're getting our guys paid to do it. That's the cool thing. Andre, do not do that. Do not do that. Do not take a 64-bit dump of an x86 process. The worst thing in the world you can do on a 64-bit machine like Chrome is a 32-bit process. If you right-click here and say Create Dump, that in essence produces a corrupt dump from the .NET World side because the information is in there, but you must use the 32-bit WinDebug must be used to debug that. You can't do it. So you must use the appropriate bitness. Bitness matters. If you have a 32-bit process on a 64-bit machine, you must either use Process Explorer from sysinternals or ProcDump from sysinternals or the 32-bit version of WinDebug. All three of those tools will give you a 32-bit dump of a 64-bit process. If you take a 64-bit dump of that 32-bit process, it's basically garbage. Okay? Because you won't be able to get at any of the .NET side at all. So everything must match. 32-bit process, you must use the 32-bit tool. And Process Explorer and ProcDump from sysinternals do the right thing, and of course the 32-bit version of WinDebug does the right thing. Everything has to match in order for you to use SOS to get at that. Okay? Sorry, I hope you don't have a whole bunch of 64-bit dumps. Okay. Yeah, somewhere over the rainbow. But yeah, it's been a while since I was at NewMega, but it's one of those amazing companies that lives forever because it was the right place at the right time. It was an amazing place. I was very honored to work there, especially being one of the first people to work there. So it was a lot of fun. So please, if anybody has any questions, please, let me get my email address back up. We had some of this stuff here. If you got any questions after this, send me an email. I'd be happy to take a look at it. And as I said, if I don't know the answer, I work with a lot of brilliant people at WinOak, and we'll try to get you taken care of. So, cool. Thank you all very much. Okay? And I'll stick around until it says 11:25 on my machine, just in case somebody's got a last-minute question, and then we'll call it a day. Is that Brian coming in?